You want to learn Python but you don't know where to start? Then keep watching this video till the end. After this video, you will already have a solid foundational Python knowledge base. I will show you how to install the Anaconda environment and then we start coding together. We will talk about the most common Python data types like integers and strings. I will show you how to work with numbers in Python as well as how to utilize variables. And we will talk about Python's built-in functions like lists and tuples and what to consider while working with them. Sounds good? Then let's get started. We will start our journey with downloading Anaconda. Therefore, we navigate to www.anaconda.com and we are forwarded to the official site of Anaconda. Anaconda itself is nothing else than a development environment. As you can see over here, I can directly click on the download button as I'm on a Mac OS. If you are utilizing a Windows or a Linux, you should also see the download sign over here. If you can't see the download sign, simply press on either one of these buttons, depending on your system. For now I will click on the download button and the download will start automatically. Once the download is ready, you should be able to see the Anaconda Navigator. You can click on the Anaconda Navigator symbol. Once you started the Anaconda Navigator, you will see the following screen. For us, the Jupyter Notebook is the most relevant, so we will simply click on the launch button over here. It might be that you have to wait a couple of seconds. Afterwards, you will see that the Jupyter Notebook opened in your browser. But don't worry, you won't need an internet connection to start coding. Jupyter Notebook is just utilizing the browser to display the information. So what we can actually do here is we can start by creating a new file via the new button. To be precise, in the Jupyter environment this is called a notebook. So we will click here on Python 3. This opens up a brand new notebook where we can actually start coding. First, we will talk about Python data types. As you can see over here, I marked the header with this hash function. So whenever we input a hash and afterwards some text or whatever, this won't be displayed in the actual code. So in the end we are just commenting here. We will start by exploring the four most common data types, which are integers, floating points, strings and booleans. Let's start with the integer. An integer itself is nothing else than a whole number. Let me give you an example. An integer would be the number 1, or another integer would be the number 2, the number 3, or the number 100,000 as well. All of those are integers. If we want to execute whatever was written in here, we can do this via the run button over here, or via pressing Shift and Enter on your keyboard. As you can see, the last number was given back by the system. This is a default behavior. If I want Python to output all of the numbers we inserted, we have to use a different approach. Therefore, we will utilize the print statement and just insert in the brackets what we want the system to put out. So in this example, I will insert a 1, a 2, and also a 3. And if I now press on the run button or on Shift Enter, everything will be put out. And this is it for integers. Now let's focus on floating points. Floating points are nothing else than real numbers. So for instance, a floating point could be something like 2.3, minus 1.6 or 34.5. Let's now focus on strings. Strings are nothing else than a sequence of characters. So a string would be something like ABC, but a string could also be 1, 2, 3, 4, or also some other terms like an exclamation mark, a $sign, and so on. All of those are strings. And as you may have noticed, you can see that before and after the string, I put a single quote. We will talk about all of this later. Last but not least, we got booleans. A boolean can be either one of two values. It can be true or it can be false. And that's basically it. Now we are ready to talk about numbers in Python. Numbers in Python are either integers or floating points. And with them we can perform operations like 2 plus 2, which is equal to 4, 2 minus 2 equal to 0, or for instance also 2 times 2 and 2 divided by 2. The same also counts for floating points like 2.3 plus 2.6 and so on. So really, with integers and floating points we can perform the basic math operations. Now let's focus on variables. Say we actually want to calculate more complex formulas. Therefore, it may be necessary to store the values we entered here before in a so-called variable. So a variable itself stores data and makes data reusable. Let me give you an example. Let's say for instance that a is equal to 5. Now I want my b to be a plus 1. So the a from over here, which is equal to 5, will be inserted in this a placeholder over here. So the result should actually be 6. As you can see, I pressed on Shift Enter, but nothing happened. This is because we need to call the variable first. So in this case I will call B and then press Shift Enter or the run button on the upper screen, and I will get the output 6. A variable could also be for sure a string like the name John. If I output this, it will display John. And a variable could also be for sure a floating point or also a boolean. You may have noticed that I used the same variable B for a string, for a floating point, and also for a boolean. This is because variables can actually be overwritten, meaning that we can reassign them. Please notice that there are some restrictions with variables. First of all, variables cannot start with an integer or a floating point, meaning that I can't do something like this: 5 is equal to a. This will result in an error. The same counts for 5.2 is equal to a. Also, variables cannot have spaces in them, meaning that we can't do something like ab is equal to 1. Instead, we would use underscores like this. This would work. We can also combine text with our variables. Let me give you an example. Let's say that a is equal to 5. And now we could display something like the value of my variable is colon, and then we say a. You can see that exactly what was inserted was printed. The a here takes on the value 5, and this is displayed in the output. However, you might ask yourself how to get rid of those brackets. Well, therefore we have to utilize the print statement again. Let's just take the print in brackets and then insert what we inserted before. And if we now print, we won't see any brackets or any quotes anymore. By the way, we can use single quotes or also double quotes. Let me show you why. Let's say we have the following print statement. In this case you will see that the print output actually looks as follows. There are no quotes in front and after the sentence itself. However, Sam in this instance, which is the nickname, is put in double quotes. For sure this also works vice versa, like this. Here we have the double quotes in front and after the sentence, and within the sentence we have the single quotes for Sam, and if we output it, it looks as follows. You can see again that the double quotes before and after the sentence vanished. However, Sam is now in single quotes. What won't work is the following. If we do take the first example over here and copy it, and now we change the name Sam with single quotes, this won't work. The same also counts for the letter case. If we use double quotes over here, this will also not work. Meaning that in the end you can use a combination of the single and double quotes, but you can't reuse them in the same line of code, so to say. Let's now focus on data structures in Python. There are 4 built-in data types in Python used to store collections of data. Those data types are lists, tuples, dictionaries, and sets. Let's start with lists. A list is a data structure in Python that is a mutable or changeable ordered sequence of elements. Let me give you an example. Let's say we have a variable called a list, which is equal to, in square brackets, 1, 2, 3, 4, and 5. This is already a list. We can output it as follows. And now we can see exactly the individual items in the list. A list is mutable, so we can say or redefine the list as follows. For instance, a list is able to I am a string, comma, 123.12, 100. As you can see, we can store multiple different data types in a list. And if we want to output it, we just call it. A list is also an ordered sequence of elements, meaning that we can actually index different items of the list. Let me give you an example. Let's say we only want the 123.12 and the 100 as an output. For this we would say a list, and then in square brackets we would define 1 until 3. And if I output this, we will get the values back. Now you might ask yourself, what happened to the I am a string, so the string value over here? Well, if we want to display the string value as well, we would say a list and then the square brackets, and this time we would say 0 until 3. This is because in programming the first instance of, for instance, a list, but in general also for other functionalities, always starts with 0. So position 0 is I am a string, position 1 would be 123.12, and position 2 is 100. Now you may ask yourself why I inserted the 3 over here. This is because whenever we index a list, it will go up until the value, but will not include the value. Meaning that when we index from 0 up until 3, for instance, this will include position 0, 1, and 2, but not position 3. The same counts for the following list. Let's say we have our list again and we have one more value like 111. To output all of this, we would need to go from 0 up until 4. This would include the 0, so I am a string, position 1, which is 123.12, position 2, which is 100, and position 3, which is 111. Be aware that we can also add lists together. We have a list, which is equal to 1, 2, and 3, and b list, which is equal to 4, 5, and 6. So now we could say c list is equal to a list plus b list. And once we call c list, our individual list will be concatenated. Let's now come to the next built-in data type, which is a tuple. Tuples are used to store multiple items in a single variable. We could define a variable as follows: a tuple is equal to tuple, 1.2, and 100. Be aware that for tuples, we normally use the normal parentheses, so those ones over here, and not the square brackets or curly brackets. If we now want to print a tuple, we could simply call it. Now you may ask yourself what the difference between a list and a tuple is. Well, while we can change lists, tuples are immutable, so we cannot change, add, or remove items from a tuple. Let me show you an example. Let's say we have one list, which is equal to 1, 1.2, and the string hello. Let's now change the initial, so the first item of our list, this one over here, to a 12, let's say. Therefore, we would say one list on position 0, which is the first item, is equal to 12. If we now call one list, you can see that the first value changed to 12. Let's say we now want to do the same with a tuple. So we take the tuple from above again, and this time we say a tuple on position 0 is equal to 12. As you can see from the output, we get an error because the tuple object does not support item assignment. However, indexing itself is supported by a tuple. So we could say a tuple position 1, which is equal to 1.2. Last but not least, we have the so-called dictionaries. Dictionaries are used to store data values in a key and value pair. A dictionary is a collection which is ordered, changeable, and does not allow duplicates. Let me give you an example. Let's say a dictionary is equal to t-shirt for the price of $12.99, phone for the price of $599, and apple for the price of $150. If we now want, for instance, to get a price for the phone, we would simply say a dictionary. Then we will utilize the square brackets and say we want the value for the key phone, which is $5.99. Let's see how the output looks like if we display the whole dictionary. And here you can basically see the key value pairs. We have seen by now that a dictionary is ordered, so we can actually index it, but we can also change the values of a dictionary. Let's say, for instance, that the value for the t-shirt increased to $16.99. So therefore we would say a dictionary, and then in curly bracket t-shirt, which is the key, and we want the t-shirt to be $16.99. If we now print the dictionary again, we can see that the price updated. And last but not least, the dictionary does not allow duplicates. Say for instance we have a dictionary like this, so B dictionary is equal to the key t-shirt for $12.99, the phone for $599, the apple for $150, and again the t-shirt for $12.99. If we now display the dictionary, we can see that the second t-shirt is cropped. This is because the dictionary only allows unique values. Thank you so much for watching this video till the end. If you like this content, please subscribe to my channel to not miss any more videos. See you next time.